Hello, everybody. My name is Ed Schwenk with PGM Recovery Systems. I'm here with my friend Ted Hill from SPS Support Product Services. How are you, Ted?
I'm doing good, Ed. How about yourself?
Great. I'm doing well. Thanks for coming and joining me this morning. I really appreciate it. We really want to talk a little bit about Ted's business, and you are the CEO of the company, correct?
That's correct.
Yeah. What is it that you guys do over there?
Well, we are basically involved with natural gas engines for the most part. We produce heat exchangers. We supply emissions control equipment and emissions analytical equipment, and a few accessory items that go along with the engine. So it's all kind of a little niche-y.
It's industrial then.
Yeah, it's industrial. Our customers are typically municipalities, cities. We do some agricultural work. You know, it's kind of sorted all over the board. But
Right. And I saw that you also have some type of tools such as diagnostic systems.
it's emissions analysis. So we are a distributor and a service center for a German-made portable combustion analyzer. It's called ECOM.
Mm-hmm.
So the power generation people, companies that service boilers, they use it to tune in the combustion sources.
Mm-hmm. So it's all different types of fuel sources that are diesel, natural gas.
Right. Yeah. There's the main is natural gas, but there's diesel, there's heavy oil, biomass, wood. So any combustion source
Very interesting.
can be tested. So they're looking at the O2 content in the exhaust, the NOx, the CO, CO2.
Right. It's all important these days.
Correct.
What do you guys offer as far as equipment? Is it sales? Is it leasing? What do you do in that area?
It's mainly sales. We can't offer leases on the portable analyzers, and some companies choose that route to be able to manage the after the sales costs of the yearly maintenance on them. But for the most part, it's outright sales.
It's outright sales.
Yeah.
So I understand that you have a patent for a particular type of what is it? A coupled device or a coupled converter?
Actually, the patent I have is on a monitoring device.
A monitoring device
for catalytic converters.
Interesting.
We do have a design and for a catalyst housing for large industrial applications, but I could not get a patent on it because I had it commercially available for too long before I applied for the patent.
Oh, that's how that works.
So yeah, but we do have a system that's a little bit different than everything else that's out on the market. All we got on that now is a trademark. So
right. So the industrial catalysts that you are offering to the market, they consist of probably both types. Monolith, foil, steel, or ceramic as well.
Ours are all foil based. Yeah,
foil based. I see. Yeah.
So the majority of them are three-way catalysts, NSCRs, and then we do build oxidation catalysts for the applications that for lean burn engines that use oxycats. But
right, oxycats. So the typical client for you would be, like you said, a municipality, and they might run a power generator.
Correct. And there's also a lot of mechanical drive applications to where they're like all around us here in this area. Eastern Municipal Water District, which has about 550 square miles of territory here,
right.
They have somewhere around 95.
We're here in Southern California, just so that you know.
Yeah, they have about 95 engines that are driving water pumps for their water system. So that's where our heat exchangers, we have a heat exchanger that it's a double wall that they can use with their domestic water system. So the water that they're actually pumping into their system, they're using to cool the engine rather than having a radiator.
Okay.
So it's radiators take horsepower. So the fan that you're using to cool it takes horsepower. Right. So that horsepower that they can use to actually drive the pump rather than to waste it on a fan.
Well, that's interesting. I didn't know very much about that.
Yeah. It's real niche-y. It's
super niche. And the fact is that those pumps are not electric. They're
natural gas.
Natural gas.
And the reason for that, and this is why it's so niche-y, is it's really a Southern California, Arizona, New Mexico, a little bit into Texas. Mm-hmm. When these cities were growing and they were planning their expansions,
right.
There was gas pipelines crisscrossing everywhere out here, but not electric.
Right.
The electric service was spotty. So it was cost so much to bring in the power to run these large horsepower pumps that they designed everything around natural gas drive.
I learned something today. That's great. You said something to me the other day when we had a conversation that there was also an application for in the mountains where there's some ski lifts and something about that. What is that?
That's actually Snow Summit Ski Resort has their own power plant. And that's because there was grid constraint coming up the mountain from
grid constraint,
Edison.
Right?
Yeah, correct.
Wow.
So they built their own power plant, and they've got their diesel generators.
Right.
They, at the time when they installed those, they put in the first emissions control system that was diesel particulate control.
Okay.
Oxidation catalyst,
right,
and SCR system.
And SCR, so all three.
Yeah.
So in the old days, say when we say the old days, would it be 10 years, 20 years ago? What did that environment look like for emission control? It's kind of evolved over the years, hasn't it?
Oh, definitely. Yeah. I mean, they now diesel particulate filters is on just about everything.
Right.
SCRs were typically on larger power plants. And then the combination of the two, I think that Snow Summit was actually the first installation in California that married them up. And
so this is all driven by regulations?
Yeah. The South Coast AQMD put that together for Snow Summit, gave them, like I say, there was no regulation. So they basically developed it for that project.
Interesting. So California seems to be always in the forefront of regulating business and industry. What are you seeing with your experience, how that's rolling across the country to different states? Is it changing the environment? Are other states still 20 years ago California regulations? Or?
Yeah, I mean, I think eventually all of the states will come close to what we've been dealing with here for 20 years.
Right.
We've had the most stringent NOx and CO regulations in the country for a long time. And when I talk to customers, we don't deal a lot with customers outside of this area, outside of the Southwest. Mm-hmm. But when I do talk to them, they're dealing with emissions limits that are probably 5 to 10 times higher than what we've been dealing with. And that's actually why we developed our catalyst housing, because everybody's catalyst, the formulation will hit the limits that South Coast set out, but the design of the housing, if you can't keep the catalyst completely sealed and you get exhaust blow-by around the catalyst, it's not getting treated, you can't hit the low numbers.
You can't treat it if it blow by.
Correct.
Yeah, that's right.
So we just came up with a system that's positive sealing, and
good.
It'll hit the numbers and stay there, give you long-lasting compliance.
So I understand that you're focused primarily, of course, on the industrial side, but having lived in California for many years, and we all know what's going on with regulations for internal combustion engines for automobiles, and what we're hearing where it might be going in the future. You have an opinion on that? Do you think that's something that is coming sooner rather than later? The sunset of the internal combustion engine in automobiles. I mean, do you have an opinion? I have an opinion. I'm just curious because you're in this industry that handles exhaust.
I have a lot of opinions. I'm not quite sure you want me to open up that box here, but I this is kind of simple way of looking at it. But I people think that buying an electric car is gonna save the planet, but somewhere someone's going to be generating the electricity to charge the car with a turbine, a gas engine, a diesel engine. You just can't rely on solar and wind. They're all great, but they don't have the reliability, and you can't use them all the time. So there's always going to be some combustion source, whatever it is, coal, natural gas, nuclear, something.
It's interesting. There's always some unintended consequences to policy change, and one would be if you put a lot of turbines up. There's a detriment to the bird population. That's one. Another is I understand that those blades are not recyclable. They end up in landfill.
That's their biggest problem.
That's their biggest problem.
Mm-hmm.
Now we talk about storage of energy, trying to supply to the grid and have a sustainable backup. There's not enough of the rare earth elements coming from mining to produce the batteries that are going to be required for the grid storage, plus the replacement of the internal combustion engine with battery vehicles. I think there's a lot of unintended consequences that will be faced that policymakers haven't thought through or brought industry into the discussion. So that's why I asked that question, to see if you had an opinion about it, because I kind of feel like it's coming, and a percentage of the auto fleet will be replaced at some point, maybe in the next 15 to 30 years. But I don't think it's going to be 90%. I think it's probably going to be more like 30% because of these issues with mines producing enough of the rare earth elements, and we need a lot of nickel, a lot of copper. It's just
the carbon footprint of those activities are
huge, crazy. They're huge.
So it's all in my opinion. I was involved with turnkey power plants before I started my business. Mm-hmm. And we got a little bit involved in some of the renewable energy. We were burning biogas until the air regulations. They used to have a little higher limit if you were using like a digester gas at a wastewater treatment plant. You had a higher NOx and CO limit than a standard carbon? Natural gas.
Does that emit carbon as well?
Well, yeah, a little bit, yeah. But that really wasn't a concern. But they tipped the South Coast AQMD lowered the limit for digester gas to the same as natural gas, to where you can use after treatment to lower it. On the digester gas, you can't use after treatment because the siloxanes and the chlorines, it poisons the catalyst.
It poisons the catalyst.
So now we have these wastewater treatment plants out here that are flaring that gas. So they're basically wasting free energy over the difference between a natural gas application and a digester gas application was about 20 ppm of NOx. So for a typical natural gas engine installation here now has to be 11 ppm NOx at 15% O2. The digester gas plants had to be, it was like 36 ppm. So the difference between 11 and 36, now they're flaring that gas and not using that as free energy.
Is there any treatment to that flare off?
Yeah, they've come up with some catalytic treatment for the flares as well. So
basically, it's an energy source that's being wasted.
Exactly.
I see.
And the wastewater treatment plants, they were actually taking it further, they all ran cogen. So they were producing electricity with the generators, using the hot water or producing steam off of the engine to use as a heating source throughout the plant. So the wastewater treatment plant uses a lot of heat. There's digesters out there that have to be kept at 98 degrees.
Sure.
That's what they use the hot water for that.
Wow.
So they were way more efficient than just a straight up mechanical drive or electrical generator.
Well,
but now, and they had a fuel source. So it just made sense. They use the electricity in the plants, they use the thermal, and they had a fuel source that was a byproduct of the process.
So now they have to buy the natural gas?
That's what they're doing.
Okay, so there's a waste of tax dollars there. You just identified. How interesting. Yeah.
Well, it's a lot of, you mentioned wind power and solar and, there's fuel cells. What I found when I was involved on that side of things was the only reason those things ever penciled out or got built was because of government subsidies. They were never, they could never stand on their own. There's the ROI on it was just not there to build them without government subsidies.
Okay.
So I'm all for different sources of energy.
Of course.
But I also think you need to be realistic about it.
Well, at some point, economics should come into play. We hope.
Yeah, let's hope.
We hope.
Yeah, I think the future is it's going to be hydrogen power. That's where all of the big engine manufacturers, they're all working on hydrogen powered projects.
Well, I have an interesting statistic for you. This is something I read recently, that the internal combustion engine, the automobile, requires a certain amount of platinum group metals in the catalytic converter after treatment for the exhaust system. However, the hydrogen fuel cell uses about 6 times as much precious metal. Very interesting. So if you do the math, you quickly discover there won't be enough platinum group metals for a large uptake of those fuel cells.
Yeah, well, that's kind of like the story. I mean, this is your bailiwick is the precious metals. It's a component of our product, but we're being told the rhodium is being driven by increased regulations in Europe and China for emissions control on cars.
Yeah, I mean, you look at the fleet of cars in Europe. It used to be dominated by diesel engines. Consumers, after Dieselgate, they started to switch over to buying petrol gasoline engines, and those require rhodium for NOx after treatment. So the amount of rhodium that's being consumed has risen the last 5 years and is continuing to rise. And so that's definitely a problem. And we see that 70% of the rhodium is mined in one country, South Africa. There's just not enough of it.
Right.
That's the issue.
It's the classic supply and demand.
Classic supply and demand. Yeah. So if someone wanted to get a hold of you guys, have you got a website?
Yeah, it's www.support-products.com.
All right. Support-products.com. Very good. Very good. I appreciate the time you brought to the table this morning and your insights. It was really good speaking with you, Ted.
Thanks for having me over.
Yeah.
Appreciate it, Ed.
All right. All right, everybody. We'll see you again.